Good news, students. It's the last section of this quarter. And as a bonus, there's hardly any work to show. You just have to use all the knowledge of exponential graphs, which is actually pretty quick. So just as a review, because this is what you have to remember, without any shifts, the basic exponential function has an asymptote at y=0. So you have to keep that in mind. That's the original. And remember that anchor point on the original is always at 0, 1. 0, 1, that is our anchor point. To help find our base, like let's say it's 2 to the x. If I plug in 1 for 2 to the x, I would get 2. If I plug in, if it's 3 to x, 1 would be 3. So what we want to do to find our base is we're going to look 1 square to the left or the right, and then that will help us find our base. All right, so we are only going to have vertical shifts and bases. There will be no left and right c value, so that's why these rules will work. Okay, so if it is growth or decay, remember growth we know is growing, and I know my base better be bigger than 1. It'll help us double check. If it's decay from left to right, and our base needs to be between 0 and 1. Our asymptote, we want to compare to y=0. Remember, an asymptote is that imaginary boundary line, and it's really going to be obvious on the graphs. And that will give us the d value. So for all of these, our equation will be in the form y=b to the x plus d. That's going to be the general form. Okay, but we're going to use the asymptote, the anchor, and 1 squared to the left and right. And it's all going to be in your head. So let's look at the first example. So I got to identify where is the asymptote. I always do find d first. So I can see my values really aren't going below that line. So since that's the same as the original, it's still on the x-axis, that means that we don't have a vertical shift. Our d is equal to 0. Notice our anchor point is still at 0, 1. That's the same as the original anchor point. So now to find our base, we're going to go from our asymptote, we're going to go 1 to the right, and that goes up 2. You want to find out where it crosses on a corner. So we were at the point 1, 2. So that means that's going to be my base number. So our general equation is going to be y=2 to the x. If you want, you can write the plus 0. It would not be marked wrong. All right, let's try another one. I've got 4, just so we get the idea. Okay, so same thing. Try to identify the asymptote. It's still on the x-axis, so that means we do not have a vertical shift. Our graph still goes through 0, 1, the anchor point. And so now since it's decay, you can still go to the right, but it's kind of hard because it's not on a square. So we're going to go to the left, and this goes up 2. So because we went up 2 but to the left, that means our base is 1 over 2. So if we went up 3, it would be 1 over 3. So our final equation is y=1/2 to the x, and you can put the 0 if you like. All right, let's have some with vertical shifts. So you can kind of see our graph bottoms out. So we're going to move our asymptote right there, which is up 2. So that means that d is plus 2 because it's positive. So now, same idea. Our anchor point is still, if you act like that's our new x-axis, so you want to pretend. So we're going to pretend that this is our new x-axis. Let's just pretend. Well, we're still at 0, 1. So I'm going to go 1 to the right, and we went up 2 units. So that means that our base is 2. So y equals 2 to the x plus 2, because now we had a vertical shift up 2 units. And let's look at the last one. We'll have a different base than 2, I promise. But the bases will always be small because of the graphs. So you'll see a lot of the same numbers over and over. So I can kind of see they bottom out, which is at -1. So remember, pretend that that is your new x-axis. So we still have that anchor point, 0, 1. And I'm going to go 1 to the left, and we go up 1, 2. Okay, I promised, and I guess I was wrong. So our base, because we went to the left, is going to be 1 over that amount. On your homework, there is more. You'll see 3, I think. So our equation is 1/2 to the x minus 1.